Welcome back, you guys. In this video we're going to be discussing non-conservative work. Your textbook, I think, titles this work done by non-conservative forces, but you get the idea. To begin with, recall the work energy theorem. This is so fundamental to what we're doing. Total work is going to be equal to the change in the kinetic energy of the system. But there's another way to look at the total work that is done. The total work might be due to both conservative and non-conservative forces at the same time. So for the total, we would simply add them together. We have work done by conservative forces, and we're going to simply add work done by non-conservative forces. Subscript C for conservative, subscript NC for non-conservative work, or work done by non-conservative forces. We also understand that the work done by conservative forces is related to the change in potential energy of the system with this equation. So essentially, if you have a positive amount of work done by a conservative force, like gravity is a conservative force. If you have a positive amount of work done on a system by a conservative force, you're going to get a change in the potential energy of the system that is a negative value. It decreases the amount of stored energy, and vice versa. So from that, we can look at a combination of what's going on here and say there's some things we can set equal to each other and get some sort of understanding of the work done by non-conservative forces here. We can say total work we know is equal to the amount of conservative work, which we know is the opposite of the change in potential energy of the system, added to the work done by non-conservative forces. But we also know that that amount, that total work, is equal to the change in kinetic energy of the system. So that connection is kind of going to be rather important for us. Looking at this side of things, we're going to solve for the work done by conservative forces. Non-conservative forces, forgive me. And we can see that this is going to be the change in kinetic energy plus the change in potential energy. In other words, if we consider that the idea of total mechanical energy, it consists of kinetic plus potential energy, then essentially, off to the side here, total mechanical energy, that's E, equals kinetic plus potential energy of the system. But likewise, a change in mechanical energy is going to be equal to the change in those two forms, change in kinetic plus change in potential energy. And since what we see is this business right here, we can say that the work done by non-conservative forces is going to be equal to the change in total mechanical energy of the system. So this is where we were headed with these initial ideas. Quick summary for you. Page 2, that's a 2 right there. Summary of these things that are sort of work and energy relationships. Let's put it that way. And these relationships between work and energy become useful for us when we're trying to analyze situations and solve problems. We know that total work is going to be equal to the amount of change in kinetic energy of the system. We know that the work done by conservative forces is going to be equal to the opposite of the change in potential energy of the system. And we now know that the work done by non-conservative forces is going to be equal to the change in total mechanical energy of the system. So with these three relationships, we can start to analyze just about any situation in terms of the energy changes that are taking place as something happens, as an object is moving, as it's falling, accelerating, anything. So thanks for watching. Review this. Please read this section very carefully and read through the examples. Speaking of examples, I will have in the next video some examples of solving problems and looking at these ideas under very specific circumstances. Thanks for watching.